In this section, our objective is to be able to use the properties of real numbers to simplify expressions and justify simplifications. Let's take a look at the 5 main properties we will be using. Commutative property. That is where the order does not matter. We can switch the places when we are adding or multiplying, and we get the same meaning from the expression. For example, if I'm using the additive property for the commutative property, 3 plus 2x squared is the same as switching the order 2x squared plus 3. Similarly, if I want to use the commutative property for multiplication, when I'm multiplying, 8 times the quantity x plus 2 is the same as the quantity x plus 2 times 8. It does not matter the order, it still gives the same result. Here's a more complicated one that uses the commutative property. 15 plus 12x plus 7x, so the quantity 15 plus 12x added to 7x is the same as putting the 7x first and then adding the quantity 15 plus 12x. So in each of these examples, something has been switched. First the 7x was at the back, now it's at the front. Here, first the 8 was at the front, now it's at the back. Here, first the 3 was at the front, now it's at the back. We switch the places. The order does not matter. Associative property is when grouping does not matter. So we look at a group, putting different groups together, such as when we're adding in the associative property, it could look like this. 2 plus 0 and then plus 5x. That's the same as saying 2 plus the quantity 0 plus 5x. So notice different things here are grouped together. Here the 2 plus 0 is in a group together. Here the 0 and the 5x are in a group together. We get the same results no matter if we group different things first when we're adding. Let's look at the associative property for multiplying. 2 times 0 times 5x is the same as 2 times 0 times 5x. Doesn't matter what I multiply first, I'm going to get the same results. See how first I grouped the 2 times 0, and here I'm grouping the 0 times 5x. It works for adding and it works for multiplying. Here's an example that looks kind of like this one, but you'll see how it's a little bit different. 15 plus 12x plus 7x equals 15 plus the quantity 12x plus 7x. Notice how at first the 15 is grouped with the 12x, but then on the other side of the equation, the 12x is grouped with the 7x, which makes sense because those are like terms. We would want to group those together and add those first. So this is the difference between when we group different things versus when we change the order of different things. Let's take a look at the identity property. The result will be the same number we started with. When we add, we're adding 0. When we multiply, we're multiplying by 1. Here is the identity property of addition. 5x squared, if I add 0, I get 5x squared. See how what I started with is 5x squared, I added 0, and I came out with 5x squared, the same number that I started with. Here's what it looks like for multiplication. If I'm multiplying 5x squared, what will keep this the same is multiplying by 1. That makes 5x squared. So again, what I started with is the same as the result, but multiplying, I have to multiply by 1. Here's another example that looks a little bit more complicated. X plus 3 times 1. Remember that anything I multiply by 1 gives whatever I started with, so that gives x plus 3. The identity property tells me that whatever I started with, the result is the same no matter what I multiplied. If I multiplied, I multiplied by 1. If I added 0. Here's the inverse property. Adding positive plus negative is 0. Here's an example of that. X divided by 2 plus the negative of x divided by 2 gives 0. A positive plus a negative equals 0. There's that example. Multiplying its reciprocals. Here's the example for multiplying using the inverse. X divided by 2 times 2 divided by x equals 1. These are called reciprocals of each other. Reciprocals is when I flip over to get the upside down fraction. Reciprocals, a over b, b over a. Reciprocals, upside down. And just for fun, here's a complicated looking example of the inverse property. X plus 3 plus the negative of x plus 3 equals 0. I'm adding a positive plus a negative, I get 0. Finally, the distributive property. The product, that means multiply, of a number and a sum or difference, such as 2 times the quantity x plus 4 is the same as when I distribute, I multiply the 2 to both the x and the 4. So 2 times x is 2x, 2 times 4 is 8. The plus is already there. That's the distributive property. Here's another example of the distributive property, making it just a little more complicated. Negative 3 times the quantity x squared plus 5x. Using the distributive property, multiplying by negative 3, that gives me negative 3x squared minus a negative times a positive makes a negative 15x. I'll give you one just a little bit more complicated than those. Negative a half times the quantity 2x squared minus 8x plus 10. When I distribute, I multiply this times everything in that quantity, and it makes negative a half times 2 is negative x squared. Negative a half times negative 8 is positive 4x. Negative a half times 10, negative 5. Here are just a few more examples of how you may see these questions asked. Based on the inverse property of addition, complete the statement. 8x plus what equals 0? Well, if I'm adding and I have to get 0, this is a positive, this needs to be negative of the same number, negative 8x. Based on the associative, so I think grouping, and commutative, so I think change places or flip them around, properties of multiplication, complete the statement. So I'm thinking of things that are grouped differently. I see the 3xy times 5xy squared. Notice the 3 and the 5 get grouped together. Then I see the x's, x here and x here, get grouped together. So what's left over to get grouped together? The y and the y squared. Y times y squared. Associative is demonstrated here because of the groupings, but because I had to move the places of some numbers, I had to switch the places and put the 5 before the other variables. That demonstrates the commutative property. Which property justifies the following equation? Justify is another way to say show or explain. So the property that shows why this is true, let's look at this side, and how did it change to get here? Well, I see the 3 got multiplied to the x squared, and the 3 got multiplied to the 5 to make 15. That has been distributed. So this is the distributive property. One more. Which property is represented, shown, represented is another way to say shown, by the following system of equations? System of equations just means more than one equation. 20 equals 3x times x squared plus 5 times the quantity x squared plus 5. 20 equals the quantity x squared plus 5 times 3x. Well, I see that 20 is the same. Nothing changed here. What changed? The 3x was in front. Now the 3x is after. The x squared plus 5 was after. Now the x squared plus 5 was in front. So they changed places. They changed the order. And when the order does not matter, that means it's the commutative property. Commutative property. Now, I'm multiplying the things that change the order, so I can be more specific and say the commutative property of multiplication. Take a couple minutes to compare and contrast the associative and commutative properties. They are very much like each other, but they are different. Can you explain what is similar and different? See you in class.